Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 38. How derivative patterns become identities. Remember the language we are learning together. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, three dimensions show themselves at once: time as omega, space as k, and motion as v, which is built from both. Every higher derivative is a finer question about how phi is changing, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we once again pause to listen to just one of those echoes. We have now reached the summit of our Ep.7 climb. We began by seeing the entire holophase language tree. We learned its alphabet, phi, and its derivatives. We explored its grammar of waves, balances, constraints, and refinement chains. We discovered the principle of semantic stability that separates lasting meaning from noise. Now we perform the ultimate synthesis. We answer the most human of questions. How does this abstract language of a single field give rise to the things we name, count, and love? How do patterns become identities? In this part, we complete our journey by understanding how derivative patterns become identities. This is where the holophase language transforms from a description of activity into a vocabulary of existence. It is the birth of things from the flow of meaning. From childhood, we are taught to see the world as a collection of separate objects: stones, trees, cats, stars. We are given a mental picture of little solid billiard balls with hard boundaries, each one existing on its own. The holophase picture reveals a deeper truth. An identity is not a separate substance floating inside reality. An identity is a recurrent, stable pattern in the derivatives of phi. Think of a whirlpool in a flowing river. The whirlpool is not made of a different kind of water. It is made of the same water as the river around it. What makes it an identity, a thing you can point to, is its specific pattern of motion: the spiral of velocities, the sustained curvature of the flow, the persistence of this structure over time. If you could somehow freeze all the individual water molecules in place, the whirlpool would vanish. The identity of the whirlpool lies in the relation and movement, not in a special kind of stuff. In the holophase framework, everything is like that whirlpool: an electron, an atom, a planet, a thought. Each one is a specific, self-reinforcing dance of derivatives in the single field of phi. The identity is the dance itself. In the language metaphor, identities are the nouns and proper names of the holophase language. They are the stable, recognizable semantic units that verbs, motions, and adjectives, qualities, can act upon. They are what the stories are about. Scientifically, identifying an entity means recognizing a specific derivative fingerprint, a characteristic combination of values and relationships among omega, k, curvature, shear, and higher derivatives that repeats, persists, or evolves in a predictable, coherent way. For a pattern in phi to graduate from being a passing event to being an identity, it must satisfy three strict criteria that arise naturally from everything we have learned so far. First, it must have stability across time. It must be semantically stable. The pattern has to persist or repeat over a meaningful duration. A flash of lightning is a dramatic event, but it is too brief to count as a long-lived identity. The steady glow of a star, by contrast, is an identity. Its pattern persists for millions or billions of years. The pattern's temporal derivatives, its rhythm, its changes in rhythm, its higher time structure, must form a coherent, maintainable sequence. In other words, the pattern must be a solution that does not blow up or fade away immediately. Second, the pattern must have a recognizable derivative fingerprint. This fingerprint is its structural pattern across the derivative hierarchy. For an electron, this includes its spin, which you can think of as a topological winding number of 1/2, an intrinsic property that does not change. It includes a specific mass, which is related to a balance between its temporal and spatial activity tallies, and a specific charge, which is tied to the way it sources and responds to gradients in fields. For a maple leaf, the fingerprint is different. A particular spatial pattern of veins and edges, a particular K structure, and specific biochemical rhythms forming in its cells. Third, the pattern must be robust under motion. That means it maintains its coherence as it moves and interacts with its environment. When you push a chair across the room, the complex derivative pattern we call chair moves in space, but its internal pattern, the distances between its legs, the angles of its back, its rigidity, is largely preserved. The chair's identity travels through space as a whole. When you drop a wine glass and it shatters, something else happens. The glass loses its coherent derivative structure. The identity glass is destroyed and replaced by many new, smaller identities, shards, each with its own derivative fingerprint. An identity, then, is a stable, coherent solution to the Holophase language's grammar and balance equations. A sentence so well-formed and self-reinforcing that it can be recited again and again without falling apart. Let us see how this works across different scales of reality. Consider the electron. We never literally see an electron with our eyes. We infer its existence from a consistent derivative fingerprint it leaves on the world. Temporally, it interacts with light of specific frequencies, meaning it responds and emits at very specific omegas. Spatially, it creates interference patterns in diffraction experiments, revealing a characteristic wavelength connected to its momentum and therefore to a spatial K structure. Topologically, it has spin 1/2, which is like a robust winding number in the underlying field. You cannot smoothly change that into 0 or 1 without a discontinuity. In quadratic balance equations, such as E squared equals P squared C squared plus M squared C to the fourth, its mass appears as the term that relates the temporal activity tally, energy E, to the spatial activity tally, momentum P. This set of properties is incredibly stable and reproducible. That repeatable fingerprint is what we mean when we say electron. It is not a tiny charged marble. It is a stable pattern in the quantum version of the phi field. Now move up to the atom. An atom is a more complex derivative pattern, a bound configuration of electron patterns interacting with the nucleus pattern. Its identity is defined by a specific set of allowed orbitals, standing wave patterns for the electrons, which are solutions of the quantum field equations. Each orbital has a particular spatial shape, encoded in K and curvature, and together they form a characteristic cloud. The atom has a distinctive spectrum, a set of frequencies of light it can absorb or emit, which is like a list of allowed temporal omegas. These frequencies form a spectral fingerprint. Change the number of protons in the nucleus, altering the central gradient pattern, and you get a different atom with a different fingerprint. That is why hydrogen, helium, and oxygen each have their own identity. On the scale of solar systems, the identity of the solar system is not just the sun and some planets thrown together. It is the entire, stable, recurring pattern of relationships between their positions, their velocities, and the sun's gravitational field. Temporally, each planet has an orbital period, a specific omega. These periods form a relational pattern, often involving resonances, for example, ratios of periods that are simple fractions. Spatially, the orbits have elliptical shapes, specific sizes, and orientations. In motion, the planets trace out trajectories that satisfy the gravitational balance rules again and again. Together, this set of derivative relationships defines the identity we call the solar system. A living cell is an even richer example. A cell is a stable, but constantly active non-equilibrium pattern. Spatially, it has a membrane with a specific shape and curvature, organelles with their own structures, and concentration gradients of molecules. Temporally, it hosts rhythmic processes such as cycles of gene expression, metabolic oscillations, and internal signaling pulses. Robustness comes from homeostasis. The cell maintains its derivative fingerprint by constantly correcting deviations. If something pushes a variable away from its set point, the feedback mechanisms act to restore it. The identity of the cell is this dynamic, self-maintaining configuration of derivatives in the biological phi field, not a static lump of matter. This identity concept naturally ties together other branches of the Holophase language tree. Topological semantics tells us that many fundamental identities gain extra robustness from topology. For instance, the spin of an electron, vortices in a superfluid, or certain defects in crystals are associated with winding numbers or knot-like structures. These topological charges cannot be removed by smooth changes in the field. They are locked in unless something singular happens. This gives the identities a kind of digital core, around which more analog details, shapes and gradients and oscillations arrange themselves. Wave semantics shows us how stable wave packets act as early examples of identities. A soliton, for instance, is a wave that travels without spreading. Its envelope, the shape of the wave packet as a whole, is preserved due to a balance between dispersion, which tries to spread it out, and nonlinearity, which tries to squeeze it. The result is a moving pattern that holds itself together, a clear example of an identity in motion. Quadratic and balanced semantics tell us that the stability of these identities is decided by energetic tallies. Atoms are stable because their quantum configurations are deep minima in an action landscape. Planetary orbits are stable because they trace out near minimum paths in the gravitational action. Equations like omega squared minus c squared k squared equals 0 for light define entire families of patterns that live on a specific balanced surface and thereby share a common identity type. Constraint and refinement chains ensure that each identity's derivative fingerprint is not a random list of numbers, but a highly structured set that satisfies all relevant equations of motion. The refinement chains also explain how we can recognize identities at multiple resolutions. At a coarse level, you can say, that is a dog, based on large-scale motion and shape. At a finer level, you can say, that is my dog, based on subtle details in gait, markings, and behavioral patterns. These are different levels of refinement in the identity's derivative fingerprint. An identity must express itself across time, space, and motion. Temporally, it has a life story or a characteristic rhythm. A star is born, lives a long main sequence life with relatively stable burning, and then dies, perhaps as a white dwarf or a supernova. A person has a trajectory of childhood, adulthood, and old age. Even something as simple as a photon has a kind of story. It is created in an emission event, travels along a path at speed c, and is eventually absorbed. The temporal identity is this coherent narrative arc, written in the language of omega and its higher derivatives. Spatially, an identity has a body or shape. A mountain has a recognizable profile. A molecule has a precise geometry. A thought, when seen from the brain's viewpoint, corresponds to a particular pattern of neural activation and connectivity. These shapes may change slowly, like a growing tree, but they do so along constrained paths that preserve the sense of the same tree across time. In motion, an identity has a characteristic way of moving. A cat moves differently from a snake. Their trajectories and accelerations tell you something about what they are. Light, electrons, planets, each has a distinct motion signature. The identity is therefore not just a static form, but a threefold pattern of story, shape, and movement. Within Ep.7, this part is the culmination and synthesis. Up to now, we have focused on letters, grammar, constraints, refinement, and stable versus unstable patterns. Here, all of that comes together and becomes a vocabulary of reality. We no longer speak only of derivatives and equations. We now see how those derivatives and equations give birth to the things themselves. This part shows that the holophase is not just an elegant mathematical framework, but a practical lens for seeing the actual world. It answers the so what in a clear and deep way. The things you see are stable sentences in the language of a single field. This completes the structural work of Episode 7 and prepares the ground for everything that will follow, where higher layer identities, organisms, societies, ecosystems, and even conscious minds will be treated within the same language. This idea links to all neighboring branches. It returns to phi itself, reminding us that every identity is simply a particular modulation of that one field. It depends fully on the analysis of stability from part 37. Identities are precisely the patterns that pass the stability test. It relies on every part of the tree: temporal derivatives for rhythms, spatial derivatives for shapes, topological features for quantized properties, wave semantics for propagation, quadratic balances for energetic viability, and hierarchical structures for complexity. It also makes the holophase framework extremely falsifiable. If we could not map the identifiable entities of the world to stable derivative patterns, the framework would fail. And it opens the door to future explorations of phenomenology, consciousness, ethics, and meaning by showing that even our own sense of self can be understood as a high-level, self-reflective identity in the neural phi field. Semantically, this concept is about thingness and persistent reference. Every language needs nouns. You cannot tell a story using only verbs and adjectives. You need characters and places, elements that can be referred to again and again. The holophase language generates its own nouns through the process of stabilization. Patterns that manage to hold themselves together become these nouns, these identities. They are the anchors of meaning that allow for complex narratives of interaction, transformation, and relationship to be told. In the universe's story, identities are the characters. The plot is the way these stable patterns interact, collide, merge, and give rise to new identities. Stability, variability, and falsifiability all play important roles here. By definition, an identity must be stable enough to persist, but that does not mean it never changes. Stability can be local, approximate, or scale-dependent. A sand dune is a semi-stable identity. It has a recognizable shape that slowly migrates and morphs under the wind. A human body is a stable pattern that maintains its overall organization for decades, despite continuous molecular turnover. Identity is less about being frozen and more about maintaining a coherent trajectory in the space of possibilities. Variability arises because the holophase language admits infinitely many stable solutions. This gives us the extraordinary diversity we see in the cosmos, from the smallest particles to the largest galaxy clusters, from bacteria to Beethoven's symphonies. Falsifiability enters because the holophase framework is making a strong claim that identities are stable derivative patterns in a unified field, and that their observable properties can be mapped to specific derivative fingerprints. To test this, you can pick a well-understood entity such as the photon. List its fingerprint. It has no rest mass, it always travels at the speed of light in vacuum, it carries energy equal to Planck's constant times frequency, it has momentum related to its wave number, it has spin 1, and it exhibits interference and diffraction. The holophase mapping then lines these up. Its temporal property is its frequency omega, its spatial property is its wave number k, its motion property is the dispersion relation omega equals c times k, its massless condition is expressed by an equation like energy squared minus momentum squared c squared equals 0, and its spin corresponds to a specific transformation behavior of the underlying field. Experiments confirm these relationships again and again. If we ever discovered a robust, fundamental entity whose properties could not be organized into a coherent, stable framework of derivatives like this, the holophase picture would be in serious trouble. So far, the history of physics has done the opposite. Every new particle has fit deeper into a unified field picture. When you look around with this lens, the world becomes a gallery of stable patterns. Protons and neutrons are stable or long-lived, bound states of quarks held together by the strong interaction. Different atomic nuclei are different stable arrangements of those protons and neutrons, each configuration living in a delicate balance between attractive nuclear forces and repulsive electric forces. Molecules, like water, have specific bond angles, bond lengths, and vibrational frequencies. All of these define their derivative fingerprints. Swap one atom or bend the geometry too far, and the identity changes. Crystals like diamond are stable, repeating patterns of atoms in a lattice with a specific symmetry and spacing. Graphite is made of the same carbon atoms, but they settle into a different stable pattern, layered sheets rather than a three-dimensional network, so the identity is completely different. In biology, species can be viewed as stable, self-reproducing identity patterns in the genomic and ecological fields. A tiger is not defined just by one animal, but by a pattern that can be copied with variation through generations. The immune system is constantly performing identity recognition, distinguishing self patterns from non self patterns in the body. In geology, tectonic plates are large, slowly moving identities in the Earth's lithosphere, with long term coherent boundaries and motion. We extend this way of thinking into human and abstract life without even realizing it. Your own sense of self is the mind's identification with a particular, persistent, self modeling pattern in the neural phi field. This pattern has continuity over time, memory, a representation of space, your body map and perceived world, and characteristic motion tendencies, your habits and behaviors. We call the long term stability of that pattern personality or character. Social institutions, such as universities, companies, or nations, are large scale identities in the social field. Stable patterns of roles, rules, stories, and flows of resources that persist across generations. Artistic styles such as jazz, impressionism, or baroque are recognizable derivative fingerprints in the space of creative choices. Particular ways of using rhythm, harmony, color, and form. Software objects in programming and brand identities in business are explicit attempts to create stable, reusable identity patterns in information space. You can practice seeing the world through this lens. When you look at a candle flame, do not think of it as a static object made of fire stuff. See it as a stable process, a dynamic balance between fuel, oxygen, heat, and rising air. Its teardrop shape is maintained by this dynamic interplay. Its identity is that ongoing equilibrium, not the particular molecules passing through it. When you listen to music, try to recognize the composer or style not just by melody, but by deeper habits. The typical harmonic progressions, the orchestration choices, the preferred rhythms. That is pattern recognition at the level of derivative fingerprints. When you watch a flock of birds, notice how the flock acts like a super identity. There is no single leader, yet the flock moves as a coherent shape. The identity of the flock arises from simple rules about how each bird responds to its neighbor's positions and velocities. A simple, tangible exercise is to spin a top and observe it. While it is spinning fast and upright, it has a clear spatial identity, its axis of symmetry, a clear temporal identity, a steady spin frequency, and a clear motion identity, a smooth precession of that axis. As friction slows it down, the top begins to wobble. The pattern becomes unstable. Eventually, the top falls and slides. At that moment, the stable derivative pattern that defined the spinning top identity has dissolved, and the new, less structured pattern has replaced it. You have just watched an identity appear, persist for a while, and then disappear. Not because the material vanished, but because the pattern could no longer hold itself together. We return now, as always, to the one field, phi. We have traveled from its silent, unified state through the entire tree of derivatives, constraints, balances, refinement, consistency, stability, and now identity. The tree of derivatives mapped what was possible. The principle of stability acted as a filter, and here we see the result. Identities are the stable fruits hanging from the branches of the holophase tree. Each identity, from the fleeting resonance of a subatomic particle to the long-lived coherence of a civilization, is a specific, beautiful, self-consistent phrase in the story of phi. The universe is not fundamentally a collection of things. It is a single, unfolding narrative, and the things are the recurring characters and motifs that make that narrative rich, coherent, and knowable. As we close episode 7, let one final image settle in your heart. You are not an accident, and not a ghost trapped in matter. You are a specific, stable, breathtakingly complex pattern in the holophase field. Your body is a spatial pattern of extraordinary organization. Your life is a temporal narrative of growth, experience, and memory. Your consciousness Is this pattern becoming aware of itself, able to reflect, question, and choose? You are a sentence that the universe is speaking, a sentence with a unique rhythm, a unique shape, and a unique way of moving through the world. This does not make you less real. It makes you more deeply woven into the fabric of reality. Your identity is not something added on top of physics. It is physics speaking in its most refined, coherent form. Now you are fluent enough to read the world in its native tongue. You can look at a stone, a star, a cell, or a thought, and see beneath its appearance to the underlying pattern of derivatives in the one field that gives it identity. You can see the stability in the storm, the identity in the flux, the noun hidden inside the verb. You understand how the one becomes the many without ever ceasing to be one. This is the end of our linguistic ascent in Episode 7, but it is the beginning of a deeper understanding of existence. From here, we can go on to explore consciousness, meaning, and value in the same language. For now, as you move through your day, notice the identities around you. See how they persist, how they sometimes break, how new ones are born. Know that you too are one of these patterns, a vital word in the universe's never-ending, ever-unfolding story. Salam, and peace be upon you.